this is 𝐁𝐨𝐤 Mrudula and I am from Kakinada. Today I am going to discuss the topic of gravitation. So what is gravitation and how this concept has came? Before knowing that how this concept has arrived, let us have some questions. Okay, let me show you something. What did I do? I have thrown this sketch upwards. But did you observe it is returning back to my hands, right? Why is it returning back down? Am I pulling it down? No, I have not. I have only applied a force to throw this object up, but I am not pulling down. But why is this object returning back? Because there is something, a force is acting on it that is bringing this object back down, right? So did you ever question yourself why the moon is not falling onto the earth? Why is it revolving around the earth? Why the planets are revolving around the sun? Did you ever ask it yourself? Have you ever questioned? Right. So to know the answers for these questions, let us dig into the concept of gravitation. How this concept came means, let us know small story behind the formulation of this concept gravitation. Okay. One day our scientist Sir Isaac Newton is sitting under a tree. Then he observed an apple falling on his head. So he thought, why the apple is falling down? Instead of staying there, why is it falling down? He also observed far away and saw the moon. Why the moon is not falling out? Why is the moon not falling onto the earth? The earth is pulling the apple. Why the earth is not pulling the moon? Is the force same in both the cases? So he thought of this and related these two concepts, right? So he further studied and said that it is because of the gravitation, that is the force of attraction there exists a force of attraction between any two particles in this universe. So this force of attraction is nothing but the gravitational force. This is when the apple is falling onto the earth because of the earth's gravitational pull. Okay. So he said there exists a force of attraction between any two particles on this universe, right? So here we have the contradiction. Why only apple is falling onto the earth? Why the earth is not falling onto the apple? Okay, we'll get that question right. So why, if there exists a force of attraction, why this object is not pulling me? Why I am not attracted towards it? Why this sketch is not attracted towards me? Right, these are all the questions, right? So to know the solution, let us consider the Newton's second law of motion, that is F is equal to ma. We know here for certain force, the acceleration is always inversely proportional to the mass of an object, right? If we consider an apple, it is of very small mass when considered with the mass of the earth, right? It is very huge. The mass of the earth is very huge. That's why its acceleration is very negligibly slow. So we can't observe the acceleration of the earth, right? But when we consider an apple, it is of very small size. That's why it has high acceleration. That's why we are able to observe this acceleration of this apple falling onto the earth. Okay. So this is the same concept that can be applied for the case of the moon revolving around the earth and the planets revolving around the sun. By putting forward all these facts, Newton has given a law called Newton's law of universal gravitation. What does this Newton's law of universal gravitation state is? So Isaac Newton has given this law of universal gravitation. Why is it called universal gravitation? Means it is applicable all over the universe for any particle of certain mass. Okay. So what did he say means every particle in this universe exerts a force on the other particle with a force called gravitational force. And this gravitational force is proportional to the product of their masses and inversely proportional to square of the distance between them. First, suppose consider two masses of mass m1, m2, and they are separated by distance r. So according to this law of universal gravitation, the gravitational force between these two masses is proportional to the product of their masses. So here the mass is m1 and m2. So here we can write F proportional to m1, m2. And they are separated by distance r. From the law of universal gravitation, what we have? This force will be inversely proportional to square of the distance between them. If the distance is r between these two masses, then F will be proportional to 1 by r square. By combining these two statements, we have F proportional to m1 m2 by r square. And by removing the proportional constant and keeping the constant called g, that is universal gravitational constant, we have F is equal to g m1 m2 by r square. This is the formula for the law of universal gravitational. Okay. So here we got the new term called capital G. What is this G? What is this G? This is the G is called as universal gravitational constant. How can we define this universal gravitational constant means? Consider two masses. This is of mass m and this is of mass m. These two are of unit masses and they are separated by a distance of unit distance. Then what we can take? Here in the place of m1, m2 and r, we can take unit masses and unit distance, that means 1, 1, 1. Then what happens to the law of universal gravitation? That means here what we are getting? The gravitational force is equal to the universal gravitational constant. So from this we can define the universal gravitational constant as the force between two bodies of unit masses separated by unit distance is called gravitational constant. Okay, and the value of G is given as 6.67 into 10 power minus 11 Newton meter square per kg square. What is the value of G means? 6.67 into 10 power minus 11 Newton meter square per kg square. Okay, so here up to now we have studied what is gravitational force and the Newton's law of universal gravitation, right? Here we got F is equal to G m1 m2 by r square, that is gravitational force is equal to universal gravitational force into universal gravitational constant into product of masses by the distance square. So from this, what is the effect of mass on this gravitational force and what is the effect of distance on this force? With the variation of the masses, how the gravitational force changes. With the variation of the distance between the masses, how the gravitational force changes. Let us see these cases. So for suppose, consider two identical masses. This is of mass m and this is of mass m. These are of equal masses and they are separated by a distance r and the force between them is F. Okay. If we double the mass of one object, that means here it is m, right? Here we are doubling the mass of the second object, right? If we are doubling the mass of the object, what happens to the force? The force will also get doubled. From the equation of law of universal gravitation, F is equal to G m1 m2 by r square. If we substitute G and m as small capital M and double the mass means 2m. So if we take that, what we get? Double the force. Okay. And if we triple the mass of one object, what happens means the force will get triple. And if we double both the masses, what happens? The force will become quadrupled. That means 4 times of the gravitational force. So here the effect of mass on gravitational force we have observed. Okay. So if we take masses are separated by distance capital R. Okay. If we halve the distance between the two objects of masses capital M and capital M, what happens means we are halving them. So the gravitational force becomes quadrupled. Okay. And if we double the distance between them, then it becomes 1/4. 1/4 of the force which was in original. Okay, these were the cases. Thank you. So here what we have studied, here we have known the what is meant by gravitation and gravitational force, and we have studied law of universal gravitation, and then we have studied the effect of the mass on gravitational force and effect of distance on the gravitational force. What is gravitational force means? Every particle in this universe attracts every other particle with a force called gravitational force. And what is the law of universal gravitational force means? This gravitational force is proportional to product of their masses and inversely proportional to the square of the distance between them. And what is the universal gravitational constant G? Its value is 6.67 into 10 power minus 11 Newton meter square per kg square. And what is the definition of universal gravitational constant means? It is the force of the objects of unit masses separated by unit distance. Okay, this is the concept we have studied today. Thank you.